All right, so today what we're going to be doing is the multiple forces worksheet. This one is a little bit more advanced. This is the next step in learning, Newton's laws. We'll be getting into free body diagrams. We'll get into friction. So now being said that, let's do number one, which is a basic one using one-dimensional motion, okay? So it should be an alert that if you see one-dimensional motion stuff, you're going to have to link it, okay? So number one says, what average force? So as soon as you hear average force, you're going to be using this basic equation. Average force, net force, resultant force, that's what you're going to be using. Is needed to accelerate a 7-gram pellet. So I'll list my force variables over here. Mass is 7 grams. All right. From rest to 125 meters per second. So I got VI is 0 because it says from rest. VF because it goes to 125 meters per second is over here over a distance of 0.8 meters. Okay. So right away I should see that this is in grams. It needs to be in kilograms. So I'll convert it. 1,000 grams, 1 kilogram. So I do 7 divided by 1,000. I get 0.007 kilograms. It should make sense that if I'm looking for force, right, it says what force, I need acceleration here so I can find force. Well, I can find acceleration using my one-dimensional motion. I look at my variables, I figure out that I'm going to use Vf squared equals Vi squared plus 2a delta x. Vf is 125 squared, Vi 0 goes away, 2a is what I'm looking for, delta x is 0.8. So I go ahead and multiply, well let's simplify. 125 squared is 15,625 equals 2 times 0.8 equals 1.6. A. Divide by 1.6. I get acceleration is 15,625 divided by 1.6. 9,765 meters per second squared. Okay, so that becomes my A. I can plug in now. F equals MA. F is what I'm looking for. M is 0.007. 9,765. F equals, I multiply. I do 0.007 times 9,765. You get 68 newtons. It's going to require a force of 68 newtons to accelerate that pellet to that speed. Okay? So let's go ahead and do the next problem. Two, if the coefficient of kinetic friction between a 35 kilogram crate and the floor is 0.3, what horizontal force is required to move the crate at a steady speed across the floor? All right, so good, let's draw this out. I got a crate on the floor. First thing you want to do, positive, positive, negative, negative. Let's label, we're pushing it across the floor, so let's look at our free body diagram. You obviously have the pushing force. We'll call that FP. You have the normal force because it's in contact with a surface. You have its weight, which equals mg going straight down. And you have friction, which opposes the motion. All right, there's our free body diagram. So if we have forces in the x and y direction, we're actually going to need two force equations. So I'll start with this. Summation of the forces in the x equals max. Summation of the forces in the y equals may. So you ask yourself, okay, what does this equation mean? It says add up all the forces in the x direction, okay? Well, I look, x direction, I go, okay, well I have positive FP and I have negative FF equals. Then you ask yourself, does it have acceleration? Okay, if it has acceleration, you leave it as max. If it has 0 acceleration, you put it at 0. Well, in our case here, it says it's moving at a steady speed, constant speed. So if you're moving at a constant speed, acceleration is 0. All right, let's look at the y direction. It says, add up all the forces in the y direction. Well, again, what are my forces? I have Fn and weight. So I go Fn minus weight equals. And you think about it. Well, the box isn't moving in the y direction, so it has no acceleration in the y direction. All right? The question says, what horizontal force is required? So, in other words, we're looking for FP here. We need to know what force is required to get this box to move at a steady speed. Well, it gives us that the surface has a mu, in other words, coefficient of friction of, what is it? 0.3. Do you see mu in any of these equations? No. So what we have to do is get mu into the equation so we can solve for it. Well, what we do know is that force of friction is equal to mu Fn, the coefficient of friction times the normal force. All right? So what I'm going to do is, because Ff equals that, I'm going to plug in for Ff. So I got Fp minus mu Fn equals 0. I can now plug in here. Fp is what I'm looking for. Mu is 0.3. Normal force. Do they tell me anything about the normal force? No. But I have an equation with the normal force in it, so I can solve for it, so I can solve for this. I add weight. I have Fn equals weight. Fn equals mass times gravity. All right? So what I do is I plug in. Fn equals the mass of the box is 35. Gravity is 9.8. All right, Fn equals 35, 343 newtons. You just put the value for G there because you've already taken into account the positive and negatives there. Just the value for G, okay? So I plug in here, 343, because that's the normal force. I go ahead and solve. Fp minus 0.3 times 343 gives me 102.9. I add 102.9. Cancels out. I get Fp equals 102.9 newtons. So it requires a 102.9 Newton force to get that box to stay at a constant speed. All right, hold on. All right. So, number 3. Again, this is going to be kind of the same type of problem here. A force of 48 newtons is required to start a 5-kilogram box moving across a horizontal concrete floor. What is the coefficient of static friction between the box and the floor? B. If the 48 Newton force continues, the box accelerates at 0.7 meters per second squared. What is the coefficient of kinetic friction? Okay, so let's go ahead and draw this. Okay, you're pushing a box on a floor. One way is positive, positive, negative, negative. You're going to obviously have a pushing force, Fp. You're going to have a normal force, Fn, the weight of the box, and friction opposing it. Okay, so for the first part, the box isn't moving. We're looking for static coefficient of friction. All right, so I'm going to label that. Static. So you're trying to find, you know that a 48 Newton force is the minimum force required to push that box. All right? So think about it. The box isn't moving yet. So when I write these forces, summation or force equation equals max, and summation of the forces in the y equals may. So again, add up all the forces in the x direction. I have Fp and Ff. So I go Fp, it's positive, minus Ff. The box isn't moving yet, it's static. 0, no acceleration. In the y direction, add up all the forces in the y direction. Positive force, negative force. I have Fn minus weight. The box isn't moving up or down, so it's not accelerating in the y direction, so this becomes 0 also. It's now asking us to solve for mu. We want to know the roughness of the surface. So what we want to do here is the same thing. We need to get mu into it. Now remember that force of friction equals mu Fn. So anytime you have force of friction, you're probably going to be plugging that in for it. So I can rewrite it as Fp minus mu Fn equals 0. Okay? So, I know that it's a 48 Newton force. Minus, mu is what I'm looking for. I need to calculate the normal force, so I can go ahead and solve for that. So again, I add weight over. I get Fn equals weight. In other words, Fn equals mg. I get Fn equals. The mass of the box in this case is 5 kilograms. So I go 5 times 9.8. Fn equals, I believe that's 49 newtons. Okay? So you have 49 newtons equals 0. Solve. I would get rid of the 48 first. Subtract 48 minus 48. I'm left with negative mu 49, negative 48. I divide by negative 49. Cancels out the 49 and it cancels out the negative. So I'm left with mu is equal to, divided by negative 49. I get 48 0.98. That is my static. All right? Kinetic. So now I got to read a new scenario. Okay? It says if the 48 Newton force continues, so you're still pushing it with that 48 Newton force. But what happens is once you get to sliding friction, there's less resisting you. If there's less resisting you and you apply the same force, you're going to accelerate. And it tells you that. It says it accelerates at 0.7 meters per second squared. So again, if I'm pushing on the box and there's friction, really nothing changes with my free body diagram. But I'm going to write my force equation because there is something that happens. Well, really, nothing changes in the y direction. So I'm going to leave that. I'm going to use the y direction because nothing changes. It's still on the surface. It's not moving up or down, so the normal force stays the same. But something does change in my x direction here. So I'm going to go ahead and write it. Summation of the forces in the x direction equals max. Add up all the forces in the x direction. I have Fp and I have Ff. So I go Fp minus Ff equals. Now you ask yourself, does it have acceleration? Well, yeah, now it does. It says it accelerates at 0.7 meters per second. So I leave that as max. Again, you're trying to find mu. Mu is not in the equation yet. So again, I plug in for that. Fp minus mu Fn equals max. I know Fp is still 48. It says it still pushes at a 48 Newton force. Mu is what I'm looking for. The normal force is 49. The mass of the box is 5, and the acceleration is 0.7. So let's go ahead and simplify that. I do 5 times 0.7. 3.5. I'm going to subtract 48. I get negative mu 49 equals 3.5 minus 48. I get negative 44.5. I divide by negative 49. It gets rid of the 49 and the negative sign. So I'm left with mu is equal to, I do negative 44.5 divided by negative 49, and I get 0.90. That's kinetic. All right? That should make sense. Kinetic will always be less than static. So that is a valid answer. Okay, so it asks, what is the maximum acceleration a car can undergo if the coefficient of static friction between the tires and the ground is 0.8? All right? So let's go ahead and draw this problem here. Okay, so we'll draw the tire. Friction is what causes the tire to move, so force of friction. All right, you still have weight of the car, and you still have the normal force, yada, yada, yada. We'll call this positive, positive, negative, negative. So let's go ahead and take a look at in the force of friction equation here. So I'm going to go summation of the forces in the x equals max. Well, the only force I have is force of friction. Okay? We want to figure out the maximum acceleration. Okay? Maximum acceleration. So I have acceleration. Force of friction is equal to mu Fn equals max. Well, Fn, let's see what we got here. I need to use y equation here to solve for Fn. Summation of forces in the y equals may. I go, well, positive, negative, Fn minus mg, which is weight, equals, the tire's not moving up or down, so it's 0. So I get Fn equals mg. I'm going to plug in for that. Mu mg equals max. Okay? So to solve for a, I would divide by mass. Cancels out, divide by mass. Cancels out. I'm left with mu g equals ax. Mu for the tire is 0.8. G is 9.8. ax. Multiply. You get the maximum acceleration that those tires can undergo. 0.8 times 9.8. 7.84 meters per second squared. All right, 7.84 meters per second squared. All right, next one, number 5. A 12 kilogram bucket is lowered vertically by a rope in which there is 163 newtons of tension at any given instant. What is the acceleration of the bucket? Is it up or down? All right, so let's draw this. So what is this? Number 5? Bucket. Attached by a cord is going to be pulling it up. So up, positive, positive. Well, it's not moving left or right, so I don't even need to do that. So tension in the rope, we'll call that Ft, and we'll call this weight mg. All right? Only force is acting. Pulling up, and the weight is pulling it down. All right, so let's write our force equation. Summation of the forces in the y equals may. Well, ask yourself, add up the forces in the y direction. I have Ft and weight. So I go Ft minus mg equals. Is it accelerating? Let's see. Yeah, it's looking for acceleration, so I need to have it. may, I leave it. The tension in the rope is 163 newtons. The mass is 12. G is 9.8. 12 ay. Let's simplify. 163 minus Let's do 12 times 9.8. I get 117.6 equals 12 AY. I do the subtraction. 163 minus second answer gives me 45.4. 12 cancels out. I get AY is equal to 45.4 divided by 12. I get 3.78 meters per second squared. Well, if it's positive, it has to be accelerating upwards. So the bucket is actually accelerating upwards at a speed of 3.78 meters per second squared. All right, let's look at number 6. All right, number 6 says, one 3.2 kilogram paint bucket is hanging by a massless cord from another 3.2 kilogram paint bucket, also hanging by a massless cord. If the buckets are rest, what is the tension in each cord? All right. If the two buckets are pulled upward with an acceleration of 1.6 by the upper cord, calculate the tension in each cord. Okay, so we have to draw each bucket independently. Okay, each bucket independently here. So 6. So this is what's happening. There's 2 buckets. So it's going to look like this. Bucket. 1, 2. All right. So let's look at bucket 1. Okay, or I'm sorry, bucket 2. We'll start at bucket 2. We'll start at the bottom here. This is bucket 2. You have positive, negative. Weight of the bucket is pulling it down. And you have tension pulling it up. All right? You have, what is this? Bucket, this is bucket 1. You have FT pulling that bucket down, right? The tension in rope 1 is pulling that one down, but you also have the weight of bucket 1 pulling it down, and then you have the tension force pulling it upwards. Okay? So let's start here. We do summation of the forces in the in the y direction equals MAY. All right? So I know FT is positive, and that's FT of this rope. FT minus the weight of bucket 2 equals, well, they're not moving, so it's going to be 0. So FT actually equals mass of bucket 2 times gravity. That's just the weight, mg, right? So I can plug in FT equals mass is 3.2. G is 9.8. FT equals 31.4 newtons. So I know that, let's call that 1, or I'm sorry, let's call this rope 2, tension 2, and that's 1. So FT, the tension in that rope, is 31.4. Let's go over here to bucket 1, and you go ahead and do it. Summation of the forces in the Y equals MAY. I have F, tension of rope 1, in other words, the upper rope, positive. I have minus the tension of rope 2, and minus the weight of bucket 1. So mg of 1 equals 0, because they're not moving. All right? So force from is what we're looking in this rope. That's the rope we don't know. It's this rope. Ft1 minus Ft2, the tension in this rope is 31.4, minus the mass of bucket 1 is 3.2 times 9.8 equals 0. So go ahead and simplify. Do 3.2, 31.4. That should make sense, it's the same. So I get Ft1 minus you get 62.8. So the tension in rope 1 is equal to 62.8 newtons. Alright? That's if the bucket's not moving. So that's A. B. Same free body diagram. Same thing. Except now it's asking is if you pull the buckets up and it has acceleration. So the only thing that changes is your equation here. Now you have acceleration. So I'm going to start here. This is for bucket 2. I'm using this free body diagram. I'm writing this one. Summation of the forces in the y equals MAY. I still have Ft of 2 minus mass of 2 times gravity of 2, mass of 2, and now it has acceleration, so I have to leave it as acceleration. Ft2 minus mass of 2 is 3.2 times 9.8, 3.2. The acceleration that it has is 1.6. So I go ahead and simplify and simplify. So I go Ft2 minus, what's that, 31.4 equals 3.2 times 1.6. 3.2 times 1.6 equals 5.12. All right, I add 31.4 Ft2. The tension in this rope is now plus 31.4, 36.5. As you can see, it's greater than it was when the bucket's at rest, because if you're pulling up, you need more force to accelerate the rope, okay? So now I want to go and observe bucket 1 that's accelerating. It's the same free body diagram. You still have the bucket pulling you down and the weight of that bucket pulling you down. So there's the two forces pulling you down, but you have the one rope pulling you up. So I go ahead and do that. Summation of the forces in the y equals MAY. Okay? I have Ft of rope 1. So this rope pulling me up. Minus, I have the weight of that bucket. Mass of bucket 1 times gravity, and that's weight, minus this rope's pulling me down. Ft2 equals, it's accelerating, MAY. Hey. Alright, so I plug in my numbers. Ft1 is what I'm looking for. Ft1 is what I'm looking for. Minus, mass of 1 is 3.2 times 9.8. Minus, Ft2, the new Ft2 is right here. It's 36.5 equals 3.2. It's accelerating at 1.6 meters per second, right? 1.6. So simplify, simplify, simplify. I get Ft1 minus 3.2 times 9.8 is 31.4 minus 36.5 equals 3.2 times 1.6 is 5.12. Ft1 minus, I do simplify here, 31.4 plus 36.5, I get 69 minus 67.9 equals 5.12, add 67.9, I get Ft1, the tension in rope 1, this rope, is equal to plus 5.12. I get 73 newtons. Alright? Just got to keep it straight here. It's the same exact problem solving method. Okay? Just keep just keep your free body diagram straight, visualize what force is, okay? And just go from there. Again, ask yourself, what forces in the y direction? Do I have acceleration? You'll be okay. All right? 7. All right, another block with friction. So let's go ahead and do this. Number 7. Okay, another block with friction here. It's, okay, so it says a 25 kilogram block is initially at rest on a horizontal surface. A horizontal force of 75 newtons is required to set the block in motion. After it's in motion, a horizontal force of 60 newtons is required to keep the block moving at a constant speed. We want to find static and kinetic coefficient of friction here, okay? So we want to find mu s and mu k. I draw my free body diagram. That's going to hold true for both. Positive, positive, negative, negative. I know I'm pushing it, so I say FP. There's friction opposing it, FF. Normal force and weight of the block. There's your free body diagram. So I'll do static first. Static. Do your force equation. Summation of the forces in the x equals MAX. Summation of the forces in the y equals MAY. It says, add up all the forces in the x direction. The forces in the x direction is FP and FF. So I do FP minus FF equals. Static, this will always be equal to 0. All right? Y, add up all the forces in the y direction. Fn and weight. So I do Fn minus mg, which is weight, equals. The block's not moving up or down, so I put it as 0. All right? Now, I want to solve for mu, but there's no mu in there. Remember that FF equals mu Fn. I know this, so I'm going to plug that in for FF. So I got FP minus mu Fn equals 0. Now mu's in my equation. You're going to get the pattern here. Anytime you're working with this, you're probably going to have to find the normal force by doing this. mg Fn equals, the mass of this block is 25. G is 9.8. Fn equals 25 times 9.8. 245 newtons. So I can plug that in. The pushing force it requires is 75. It's the force that starts the motion. 75 minus mu 245 equals 0. I subtract 75. I get negative mu 245 equals negative 75 divided by negative 245. That cancels out the 245 and the negative. So I get mu is equal to, let's do 75 divided by 245. I get 0.3 for my static. All right, kinetic. So, same free body diagram. Same in the, nothing changes in the y, but now stuff changes in the x. So let's go ahead and write my x equation here. FP minus FF equals, now you ask yourself, is it accelerating? The problem says, oh, it's still moving at a constant speed. So that becomes 0 because it's moving at a constant speed. All right? So if I look at this, FP is now, well, I got to get mu in there. So again, I do the same thing. I go FP minus mu Fn equals 0. I know the normal force, it's the same as the other one. So I know it's 60 newtons that keeps it moving at a constant speed minus mu Fn is 245 equals 0. Subtract 60. I get negative mu. 245 equals negative 60 divided by negative 245. Cancels out both things. Mu equals 60 divided by 245. 0.24. Should make sense. This static always has to be greater than kinetic. And in this case it is. Alright, good. Number 8 says, if a man weighs 900 newtons on Earth, what would his weight be on Jupiter, where the acceleration due to gravity is 25.9 meters per second squared? So this is just doing, understanding the relationship of mass and weight. Okay, so let me erase this real quick. So what we need to do is we need to find this guy's mass, because his weight is in newtons, and he's, 900 newtons. That's the force he feels in his shoes. His weight changes when he goes anywhere that's not Earth. Okay, like on the moon, it's less. On Jupiter, it's probably going to be way more. Okay, so what we need to find is we need to find his mass, because his mass doesn't change. So when we look at our basic number 8. When we look at our basic equation here, weight equals mg. All right, the weight he is 900. His mass is what we need to know so we can find, and on Earth he weighs, the acceleration is 9.8 meters per second squared. So I divide by 9.8, I get his mass. His mass is 900. I get 91.8 kilograms. Okay, so now I know that's how much his mass is on Jupiter, but I know Jupiter's G is 25.9. So on Jupiter, G is 25.9? 9. So weight is equal to mg. Weight is what I want to know. His mass is 91.8. The new G is 25.9. So I plug in. Weight equals. I do 91.8 times 25.9. I get, what was that? 2,377 newtons. So he feels 2,377 newtons instead of feeling 900 newtons. Okay, way more gravity on Jupiter than there is on Earth. All right, keep rolling. Number 9. Number 9. The largest caliber anti-aircraft gun operated by the German Air Force during World War II was a 12.8 centimeter Flank 40. This weapon fired a 25.8 kilogram shell with a muzzle speed of 880 meters per second. What propulsive force was necessary to attain the muzzle speed within the 6 meter barrel? Okay, you hear one-dimensional motion stuff. So let's go ahead and separate this between force stuff and one-dimensional motion. All right, so the weapon, so it gives us mass. The mass of the projectile is 25.8 kilograms. All right, it obviously starts from rest, because when you fire a bullet, it starts from rest. Velocity final, the exit velocity is 880 meters per second. The distance it travels is 6 meters during the time it speeds up. I want to know the resultant force, so I can use this equation. I'm looking for F. It should make sense that I need A. Well, I can get A from here. Okay? I look here. I'll use VF squared equals VI squared plus 2A delta X. VF is 880 squared. VI 0 goes away. 2A delta X is 6, so I get 880 squared. So that's 774,400 equals 12. A. Divide by 12. A equals 9.8. meters per second squared. Alright, so I can use that over here. A is equal to 64533 meters per second squared. I plug in F equals mass 25.8. 64533 force equals newtons. A lot of newtons. 1 million newtons. Alright, to get that massive shell to travel far, far distances. Alright? Okay? 10, last one here. Okay, let's see here. 10. Says, a car is traveling 50 miles an hour on a horizontal highway. If the coefficient of friction between the roads and tires on a rainy day is 1, what is the minimum stopping distance that the car will stop? Okay, so we got to find acceleration here. So let's draw again that tire. Okay, tire here. The only thing stopping it is friction. Let's say it's going that way. It's friction. I have normal force. I have weight, which equals mg. So let's look at the force equation here. I got summation of the forces in the y equals may. Summation of the forces in the x equals max. Alright, so I go ahead and solve here. Add up all the forces in the y direction. Positive, positive, negative. I know that it's Fn minus mg. It's not moving in the y direction, so it's 0. The only thing I have here is Ff equals max. It does have acceleration. So Ff is equal to mu Fn equals max. All I did was sub in for Ff. Well, I gotta find Fn here. I add mg, so I get Fn equals mg. I'm gonna plug in for that. I get mu mg equals max. I divide by mass. Mu g equals ax. All right, the coefficient when it's rainy is 0.1 times 9.8 equals ax. 0.1 times 9.8, 0.98 meters per second squared. Rainy. So let's find the other acceleration while we're at it. It's literally the same exact thing, except you're going to plug in a different mu. So I'm just going to go right here. I have mu g equals ax. The only thing that changes, I have a different coefficient of friction, which is 0.6. So I do 0.6, 9.8. I get 5.88. Dry. So now it becomes a one-dimensional motion problem. All right. It starts at 50 miles an hour. VI equals 50 miles per hour. VF, we want to figure out how fast it stops. We'll do rainy first. A is, well, draw it. If we have positive and negative, it needs a negative acceleration, so it's negative 9.8 meters per second squared. I want to find delta x. I got to convert to miles per hour. I get rid of hours. 1 hour, 3,600 seconds. Let me go get a conversion from miles to meter real quick. I looked this up just for the sake of time. There are 1,609 meters in 1 mile. Miles cancel out, hours cancel out. I'm left with meters per second, so I get 50 times 1609 divided by 3,600. I get 22.3 meters per second. I'll use this one. I look at the variables. Vf squared equals Vi squared plus 2a delta x. Vf is 0. Vi is 22.3 squared plus 2a is negative 0.98 delta x. So I get, let's simplify that and that. I get 0 equals 22.3 squared, 497.3 plus, I got 2 times 0.98, I get negative 1.96 delta x. I subtract 497.3. Divide negative 1.96. I get delta x is equal to 497.3 divided by 1.96. I get 253.7. 253.7 meters. All right. So it's going to take them a distance when it's raining of 253.7. So I'm going to use the same exact equation here, but I'm using a different acceleration. Okay, so when I plug in here, I do Vf squared equals Vi squared plus 2a delta x. Vf squared is, what is it? 0, sorry. Vi is 497.3, that's already squared, plus 2. A is now negative 5.88 delta x. So you go ahead and solve. Subtract it over and divide. You get delta x. I'm just going to do that. I'm going to save steps here. So I'm going to subtract the so basically what I do is I subtract the 497 over and then divide by whatever you multiply over there. So I get 497.3 divided by parentheses 2 times 5.88. I get 42.3 meters. So obviously the car's going to stop a lot faster when it's dry as compared to when it's raining. All right? Please use free body diagrams, follow the steps. Ask yourself the questions ahead. Okay, it says add up all the force in the x direction. Look at your free body diagram. What's the force in the x direction? What are the forces in the y direction? Is it accelerating? Is it not accelerating? Those are the questions you got to kind of ask yourself in your head. Okay? Good luck.